What is statistics actually? Statistics, as you can see, that deals with the collection, organization, and analysis, interpretation, and presentation of data. So, statistics, those who haven't studied, actually, we are using statistics in our day-to-day life. Even those who haven't studied, they also study or use statistics. Statistics basically a figure, that we use in our day-to-day life. For example, in 5 million people have been died due to, or 10 million people affected, or, in COVID-19, due to COVID-19, many people have been affected. 30% of remittances, the GDP is coming from the remittances. All these statistics actually we use in our day-to-day life. But the question is not this simple, the data. The question is, how does this, or where does this data actually come from? When we say that let's say 5 million people, are living in Kyrgyzstan, for example, the population of Kyrgyzstan is 5 million, then how do we come to know that 5 million people? Have we counted individually? Of course not. Then what are the parameters, and that helped us to know that the population of Kyrgyzstan is 5 million, right? A statistics basically is a science, which is based on certain principles, certain fundamentals, and also at the same time an art. Because when you draw these kinds of charts, for example, when you draw these kinds of tables, what is this? This is an art through which you are trying to arrive at certain conclusion, right? This is science because it involves a lot of mathematics. As you can see, the name of the title of the subject itself contains probability. Your probability means the chances of occurrences, and probability. When we are going through the subject next week, we would be going into the detail of probability, that how these chances, although they are chances, but again can be learned through some techniques, some ways or some tools that we are going to use to know about, or to know these figures, right? So statistics, as I have written here, that when you collect the data, okay, what is data, how to collect this data, that all we are going to learn in this course. That even what data is, I know that most of you, or in fact all of you, know what is data. Okay, that when it comes to data, the first thing comes to our mind is a mathematical figure. Okay, that for example 5 million people, or 6 million people, or 10 million people, so that's data. But in depth, actually, in case, there is a lot of hidden meanings of those figures that are, or which are lying within the concept of data. Okay, so we would be exploring this concept, because eventually we have to analyze the data. So we should know what data is, not simply, right? So right from the beginning of collection, that how are you going to collect data, you must have heard, sometimes even you might have received a call from somebody asking you a few questions, right? And so what they are doing, actually, they are trying to collect some information from you, which would be transformed into a data. Okay, and then that data further is going to be organized, and then analyzed, and then interpreted. So when it comes to interpretation, and analysis, this is not going to be just by using some fundamentals or mathematical figures. No, we need some tools. Actually, we need some tools, we need some equipments to analyze the data. And for that data, we actually use a different sometimes we use softwares. For example, some people, like, we are going to learn SPSS, some people learn R, and what you call MATLAB, and there are different softwares. Why? Because without or even basic, Excel, and these days Python is very common. I would be teaching you SPSS. My course, theoretical as well as practicals. So in each class I would be discussing with you the theoretical aspects of the concepts which I would be dealing with, and at the same time the application of those concepts in software, and try to analyze the data. And in the end of the classes, in the last week particularly, interpretation, that how interpretation means that not only interpretation but also how can you actually arrive at the conclusion. Okay. That is why analysis, further interpretation, and then presentation of data. So presentation of data, or I would say the effective presentation of data, is possible only when you have analyzed or interpreted correctly. And now, but I know when it comes to statistics, we actually do not know exactly that whether our data is really accurate, because sometimes, let's say I say here, the example I gave, 5 million people living in Kyrgyzstan, but at the same time you read another research paper from World Bank or IMF or any other international organizations, very sincere or serious organizations, and you learn that no, the population is actually 6 million, or the some papers say that no, the actual population is somewhere 5.50, 5.5 million people. So, and why? Because the entire notion of statistics is actually based on the probability, based on the collection of data, which is sometimes, uh, I would say very accurate and sometimes not accurate. So what are the reasons that our data is not sometimes very accurate? Maybe the problem is we couldn't collect the data properly, we couldn't make the sample that we are going to learn in this class, and maybe our selection of respondents was not accurate, or I would say effective, or I would say it happened somehow meaningless. So many reasons actually could be held responsible for wrong interpretation. Okay. And eventually, if the interpretation is not correct, we know that presentation of data is not going to be effective. If you look at the research paper, and I'm sure that all of you might have seen some research papers, ever or howsoever the introduction effective is, howsoever the literature review you have done, nicely, but if the interpretation of data or the analysis of data is not accurate, chances that your paper will not be, published or receive any attention from the audience, from the reader, from the publisher. Right. So we have to be very careful when it comes to the analysis and interpretation. Okay, we will be learning all these steps, slowly. Now, my second question, or in fact, the very important question, where does this term come from? Like, why do we call it statistics? Okay. Probability is a part of that, that we used in statistics actually. So it is, probability is not holistically statistics. Statistics, if it has, in next slides, I would be learning about the types of statistics, and then which is descriptive and inferential statistics. Probability comes under inferential statistics, okay, that we use. But what is this statistics, and where does this term actually come from? So I'm not going to answer this question right now. Maybe 5 to 10 minutes, I will come back and I will explain what is this, and where does it come from. Now, having understood the importance or the meaning of statistics, which again I have said that involving collection of data, presentation of data, and then I'm now moving on to basics of statistics, right? Or sometimes we call it the types of statistics. Okay, statistics basically are two types. One is descriptive statistics. Okay, you can see the word coming from description, right? Description. not analysis, only description. And next is inferential statistics. Okay, so let's understand what is descriptive statistics. My today's class and my next class is all going to be about descriptive statistics. And on Friday, we would be seeing the application of descriptive statistics in SPSS software. Okay, now, descriptive statistics basically consist of methods for organizing and summarization or summarizing information. Let's say how many people are actually driving a car, driving cars in Bishkek. If I ask you this question, so what you are going to do, first of all, you are going to collect information from, you would contact the car companies, maybe you would contact the households, maybe you would contact or you would go each and every single house and ask questions like what happens in census, census that is being conducted in every 10 years, to know about the population, and to know about the each and every information, related to the population. So this is the one way that you collect the data. And after collection of data, the second very important part is that how you are going to organize the data. For organization means that you would tell me that, Mr. Kashif, in Bishkek there are, let's say, different ages, people living 18 to 25 or 25 to 35 or whatever you like. Okay, and then you would tell me that male and some female are living. Okay, this is the second part. And maybe you would tell me about the rich and the poor people, or rich or poor is not defined in such way, but low class income or a high class income. So this is all actually about organization of data, that how you organize the data, right? If you do not organize the data, what would happen? You would simply, end up messing up with the all information, because you say, hey, there's a guy, this guy actually using Mercedes, for example, or using BMW, or so. Who is this guy? Okay, where does he come from? What is his background? What is his income? What is his age? Likewise, so we have to be careful when it comes to the organization of data. The next is summarization, that how you, because now it's not going to be possible that you are going to tell me that, okay, I have 1000, I have collected information of 1000 males or females, first person has Mercedes, second person, and he is, let's say, 18 years old, and he is, rich, blah blah blah, and second is female. So are you going to give me information like this? No, of course not. You are going to summarize this information, through the charts, through the tables, through the graphs, so this, if you make charts or graphs, then what you do, you collect all information, in a very, I would say, accurate manner that can be further analyzed, and you can actually arrive at the conclusion. Okay, so when organization and summarization of information, okay, that is basically called the descriptive statistics. So you can see here the construction of graphs. I have written charts, tables, calculation of various descriptive measures such as averages. Now, I'm sure that all of you, are aware about the averages, right? Averages, at least you must have heard that the mean, the mode, the median. But in statistics, I must tell you that I'm talking about the simple mean, simple mean, that for example, there are three people, and that is their score out of 10, 3, 4, 5. And if I ask you the average, so simply you calculate like this, isn't it? 437 plus 12, and then the average score is 4. So this is mean. So descriptive statistics also includes averages, but I have used the word averages, not average. Meaning by that, then there is not one type of average actually. there are several types of, average, and that is again we are going to see in detail probably tomorrow. Okay. Now, next is measure of variation. That's a very important concept, actually, measure of variance. Sometimes, descriptive statistics actually, like organization of data, collection of data through, presentation through charts, graphs, seem to be, very simple. But actually, this is the base of statistics. I must tell you that inferential statistics cannot be effective, or cannot help you to reach conclusion, refers to the dispersion of data, that how long or how big your data is. For example, if this is my data, so how big your data is, like what is the dispersion. We are going to see in detail. Next is percentiles. We would also be dealing with percentiles. So I hope you got the point. I will let me finish just description, inferential statistics, and then I will come to your questions. Now, I know you might be having some doubts now, but just be with me, and all doubts would be clear before we end this session. Okay, just bear with me for some time. Now, inferential statistics. As the word itself, you can see coming from the word, the inferential word itself coming from the word infer, that you infer some information, from somewhere, or that somewhere, just we are going to discuss. So it consists of methods for drawing and measuring the reliability of conclusion. Okay, drawing, that you are going to draw some conclusion. Okay, you are going to draw some information. Okay, or let's say in case of data, you have this much big data. For example, this is your big data. Okay, now you cannot collect this whole data, right? Or let's say this is the population of Bishkek. Okay, Bishkek population. And if I ask you, can you tell me about something, or something about the population of Bishkek? So of course you are not going to talk to me, or to inform me about the whole population of Bishkek. What you're gonna do, you're gonna take small information from here, from somewhere, from here, and then you will be telling me, right? So this is basically we call infer. Right. Now, before we move on to what is inferential statistics, okay, and the importance of this, let me just very quickly come to a very important, concept called difference between the population and sample. Okay, and then your doubts would be mostly, clear from here. As I said, inferential statistics is about inference, drawing conclusions, and I gave you an example. Let's say that this is my population. Okay, this is my population. Population could be anything, not necessarily the people. It could be population, could be, could be items. For example, I want to conduct a study about trees, tree. And then for example, how many trees are being cut every day, or how many trees have been destroyed in 2021 so far. So tree is my population. Okay, although population means the number of people living in a particular domain or region, but in statistics, population along with that number of people, the meaning is very diverse. Okay, for example, I want to perform a study on computers, on laptops. So laptop computers would be my population. Okay, whatever my area of study is, and the elements which I am actually considering is actually called population. Okay, so this is my population. I ask you that, hey, can you tell me how many trees? And that there are trees in Bishkek. We can see there are many trees. Yeah, everywhere there are trees. So I can see there are many trees, and I say, can you can you do a research about or do some analysis about the trees? And you say, Kashif, it's such a big, area, although Bishkek seems to be small, but when it comes to doing research about trees, one cannot do, because how can you count individually? So what you do, you take simply a small sample, okay, and that's called the sample. Right. So what you do, you take small, maybe 6, 700, or whatever the convenient for you, whatever the number convenient for you, you are going to collect, and that's called the sample. So that's why I use the word, in inference, that information that you are driving from the population. Okay, because why? Primarily that you cannot actually collect whole information from your population, so you have to rely on sample. Now the second question is, sir, if the population is small, then of course you can go for that. If you think that population is so big, or too big to cover, then you go for the sample. We will be looking at the difference between population and sample, in detail, and then only it will be clear. Because I tell you, if you don't understand the concept of population and sample, you cannot move on to actually even for your own thesis in future, either it is your master thesis, your PhD thesis, or your any research. Okay, so let's spend some time on this concept, and then further we move on to. So what is population? As I have said, the individual. But again, remember that here I don't only mean the people. Here I also mean, items of all individuals or items under consideration in a statistical study. Are you getting my point? In a statistical. Okay. So the collection of all individuals or items under consideration. So whatever, as I said, trees. Okay. In this case, our collection is the collection of trees, right? The item, maybe the population, maybe the people, maybe animals, maybe cars, or whatever. Okay, or maybe the patients, maybe the hospitals, maybe the government banks or the private banks, whatever. The collection of all items under consideration in a statistical study is called population. Okay, and there's a very fine statistician who says the interest of study is actually called population. The interest of study, of your study, of my study. For example, I did PhD in finance, and I worked on banks actually. So for me, my population was bank, or the banks in Middle East. That was my PhD about. So it could be anything. So the interest, that interests you actually, or where you are supposed to, what you are supposed to explore, that's called the population. Now what is sample? Let me just change the color. What is sample? Sample is actually we can say a subset of population. Because this information, again, you are deriving from here, right? You are deriving from here. Therefore, this is not something, I would say very new. No, this is actually because it was very difficult for us to cover, and that's why we are getting information or deriving information, from the population, right? Here, now basic differences, or what you call the technical differences, when it comes to the difference between population and sample. I hope you understand. I'm just writing fastly. Let's say I need to know the average. So average, as you know, that we define it as X bar, always X bar. X bar means it refers to the average. Okay, average particularly, and we also call it the mean, and mean is our average, right? When it comes to the population average, the average of population, it is denoted as mu, M, and just let me draw again like this. We are calculating the average of sample. It is called X bar. Okay. Formula remains the same. We call it sigma x divided by n. Here also sigma x divided by n. Let me just little bit explore those who are not from mathematics, background. Of mathematics background. Let me just explore for them. So what is this x? This x basically is our let's say the tree, for trees, for example, or the population. Okay, let's say I want to know the average height of, I'm writing here, average height of my class. Okay, in my class, I can see now there are 31 students. These 31 students have different heights. Okay, so someone has 165, someone has 170, someone has 185, very tall, someone is very, someone is like, 140, and it could go on. And that's basically called our x. Okay, called our x. And simply when we do the total, and it is called sigma. Sigma means in mathematics called total. So it is called total. Sigma means total. Okay, so sigma, how we are going to use sigma, this is our total. So we call it sigma x, which is actually we get the number, whatever the number, and divided by n. N means number of observations. Let me write down. N means number of observations. Number of observations. Okay, so what we're gonna do, we're gonna simply use sigma x divided by big N. Okay, so this is our formula in total, and the mean formula. And this n refers to this number of observation. So what is going to be the formula of mu? So we can write here, mu is equal to sigma x upon n. Okay, let's say that there are three students, whose height is there are, let me just do a small question. There are three students whose height, okay, 140, 150, 160. Okay, so what we're gonna do in mu, sigma x, so this is our x. Sigma x means total, so 140 plus 150 plus 160 divided by how many students? 1, 2, 3. 3, and it's gonna be how much? 160 plus 300, 450, right? Divided by 3, 313. So average height is of population, average height is 150. Okay, now how about the sample? Actually, there is no difference. The same thing. I just imagine that this is not my population and this is simply my sample. So when it is my sample, I would use this word, that's all. And instead of this would be like this. Okay, our next question is, because the population is very big, as I have already mentioned, that sometimes, why do we need sample? Because we cannot cover the population, and that's why we need sample, isn't it? Imagine that population is so big that I cannot, learn this mu. Because for mu, what do you need? You need sigma x, you need the total of x. But this x is so big, or let's say not only big, but also uncertain. Some informations are sometimes very uncertain, right? So if we don't know 6 and we also don't know the number of observations, the total number of observations, then how can we find out, find out this mu, right? How can we find out this mu? Is it possible? Not possible. But can we always find the mean? Yes, we can always find the mean, this x bar. Why? Because we are deriving information from the population. We are creating the sample. It is we who create the sample. And that's why to find out, to figure mean is not difficult for us. But mu is always, but difficult, or most of the time it is unknown, Now, so what we do generally, let me give a small note. Generally, what we do, generally what we do, we actually assume that our mean is our mu. I tell you how. Actually, you know it, Uh, Let me write first of all, generally, mu is unknown. Generally, mu is unknown. We don't know that mu. So what we do, we assume that our mean is actually mu. Now, but you may say, Kashif, this is not fair, because the average, here chart, yeah, the average of this sample cannot represent the average of this population. But in day-to-day life, generally, this is the way we speak. Actually, this is the way we see things happening, right? When I, for example, in day-to-day life, what we talk, how we talk about the average, the average height of, let's say, I give you an example. Some countries, the people of some country are tall, some are short, but it does not mean that in that country, particular country, that all people are tall. Or it does not mean that, for example, in some countries, if on an average people are short, it does not mean that all people are short. Or some have blonde hairs, does not mean that everybody has got blonde hairs. Or somebody has black eyes, does not mean that everybody has got black eyes. So what we do actually, we talk, what we consider the averages. For example, we went to, let's say we go to China, for example, and we find that people are comparatively short. We see some people are short, and we come back home. We say, hey, look, what the Chinese people are actually short, or the Chinese people are tall, or if just we have seen few people there, or in America, or anywhere in the world. Why? We do this, what you call this kind of observation, this observation. But when it comes to analysis, the actual analysis, we find that the figure is not true. The what we were doing is, or what we are thinking is not correct actually, right? So that's why I wrote that most of the time our mu is unknown. So we assume that our mean is actually mu. But you can ask me a question that no, this is not true, and I agree with you that this is not all the time true. Actually, it can lead to some errors, it can lead to some confusions, and that confusion and that error we have to keep in our mind, while solving the questions, while doing the research, that whatever the data we have collected from the field, is not going to accurately represent. But it all depends on statisticians, researchers, that how they collect the data. Okay, the whole, if time permits today or maybe tomorrow, I would be discussing in detail that what are the things that you have to keep in your mind when it comes to collection of data, when it comes to as I said, the description of the descriptive statistics, you have understood this collection of data, but how to collect the data, actually, that is the thing that we have to deal with very carefully. If we make make a mistake there, then it will lead to a big error, right? So population mu is very much unknown. What we do in these cases, we assume that our mean is actually the mu. Okay, I'm not going to use the word population mean or sample mean. I would be using the word mu and mean. So when I say mu, you would understand that I'm referring to the population mean. Okay, let's
I have a question.
Yes, please.
Are you hearing me good?
Yes, yes, yes. I can hear you. Yeah. Please go ahead.
As I understood, for example, we have a question to calculate average quantity of students of university who is writing by right hand.
Okay.
And we have 3 classes. And as I understood, class is like a sample, and we should calculate average quantity of each class.
Okay.
And average of 3 classes we are calculating again, and we are receiving population.
Oh, Atay.
It's like that.
Atay, I got your point. Just give me 10 minutes, and after 10 minutes, your problem would be solved. Okay. Just give me 10 minutes.
Thank you.
Yeah. I will come back to you then. Let's understand, and Atay has also asked this question, and actually I was going to teach that. I was going to touch, the topic, the difference between the population and sample. Now I'm going to write like this, this time, population versus sample. Population versus sample. It's like a fight or the competition between what is population, what is sample. Okay, that we will understand now, in a better way. The question, and you would tell me actually. Let's say the average height of people living in Kyrgyzstan, because I'm living in Kyrgyzstan, so Kyrgyzstan is always on on my mind. Now, can you tell me, is it a population or sample?
Population.
A population.
No, it's sample.
Population.
Population or sample?
It's sample, because we cannot
sample.
pick every individual person and measure their height. It's not possible. So it should be sample.
Population, since it's big.
So here it is indicated of all people, right? So it's probably population.
Probably it will
from
be.
Which we derive what?
Anna, I didn't get you. What did you say?
No, here it is indicated that the height of all of people living in Kyrgyzstan, so it is probably a population.
Very good, very good. So this is basically, as she said, that height of people. So I haven't mentioned, the class of people, or the rich people, the poor people, the old people, the young people. I'm just talking about the people, or let's say, I haven't categorized actually, and that's why this is my population. Actually, I'm referring to the population. Now, next question, let's say just I changed the language. I just changed the language. The average height of 2,000 males living in Kyrgyzstan. Now, because I am talking about the 2,000 males, okay, again, draw this picture. So this refers to sample actually. Again, draw this picture. In Kyrgyzstan, I don't know how many males are there. Let's say 3 million or 4 million, I don't know, right? But I'm just talking about the 2,000 males. Okay, I'm just talking about the 2,000 males, just 2,000 males. So that's my sample actually. Okay, one more question. Let's say that now, Atay, is it clear now?
If it will be the question, how many people with height 190, it will be sample.
No, we have to define that are we actually talking about the whole, the all people, or just a few people from that particular country or city? Or for example, I want to know the average height of my university, or OSC Academy, the average height or average score, let's say average score of OSC Academy. Okay, OSC Academy, the average score of OSC Academy. So if I say average score of OSC Academy, means that this is my population because I am considering the whole academy, the entire academy. But if I say the average score of, you know, MA class, or let's say the females, average score of females of my class, and my class is MA in economics and governance, right? And that actually would be called as the sample. So if I say the whole class, let either it is 10 students, 15 students, 20 students, 30 students, 100 students, the whole class, that would be called as the population. But if I talk about the portion of that, the one of the parts of that population would be referred to as sample. Okay.
Okay, thank you.
Yeah. Yes.
Mhm.
What if it's like OC Academy score in 2021? Is it population or sample?
2021. Well, depending on your question. For example, if you are considering the whole population of OSC Academy, because for example, Academy is running 2-3 courses, you know, and you are considering all the courses, then of course it's going to be population. But you are specifically, you know, moving on to because let's say in OSC there are 200 or 300 students, and you are performing a study on 50 students. So these 50 students are actually representing the whole population, the whole OSC Academy, right? As I said that many people believe that you know, for example, Japanese like sushi, or I think it's coming from there. They eat sushi a lot, but when you go to Japan, you hardly find people eating sushi actually, right? So because when you visit there, you meet a few people, your friends, you know, maybe your relatives living there and the relatives' friends. So you meet, let's say, nearly 100-200 people. But actually, the population of Japan, I think, more than 300 million something. So that is not actually, you are not covering the whole population. You are just covering one small section. It could be a debatable that can we say that just by looking at or by seeing few people are not eating sushi, so in all Japanese do not, you know, that's actually what we are talking about. I hope it is clear.
Yes.
Okay, very good. Now let me come back to my question that I you know, raised in the beginning of my class. Let me just see how much time is left. Okay, so we have 30 minutes more. Let me just very quickly come back to my question, that where this term and why do we call it statistics actually. Okay, so you know that when it is population sample, okay, population and sample, I as I told you that mu is average, but it is the average of population, and mean is also an average, but it is an average of sample. I wrote capital N and small n. So when it is capital N, okay, it refers to the number of observation of population. When it is small n, it refers to the number of observation of sample, right? Small n. So again, the same thing. So number of people living here, it refers to this n, and I take small sample, okay, and it refers to small n. It's the same thing like average. The next is called deviation, standard deviation. I will be dealing with, you know, I will be discussing in detail standard deviation because that's very important concept of statistics. Tomorrow I will be, you know, and we will be together, you know, solving some questions, and then we will also of mean from the n, from number of observations. Okay, so just for short time I am writing here, but later I will be covering. So we call it standard deviation, and the same standard deviation we call this ST. Okay, this is actually theta bar theta bar, or but in you can actually write this, okay, standard deviation. And the next is called the variance. Variance is nothing but the square of standard deviation, the square of standard deviation. Don't worry about these two terms. Tomorrow, if you have doubt, tomorrow it will be clear. There will be no problem at all. Okay, now all this actually big mu, or sorry, mu, big N, standard deviation, SD, it is called parameters. And all this small n, small, or x bar, SD, called statistics. Clear or not clear? This is called statistics and this is called parameters. Now, if you, again, why do we call it statistics in day-to-day life? Because actually most of our observations are actually based on statistics. Why? Simple answer, which I have said maybe 100 times so far, because of the population not available all the time, because this is not available, that's why we have to rely on it, right or not? And the entire notion is called statistics, and that's why the name of the subject is also called statistics. Okay, so parameters and statistics, that's very important question. I can also ask you in exam that what is the difference between the parameters and the statistics. Okay, just you have to keep it in your mind. Here, can I write this? Yes, I can write this, that it refers to basically what we can say, actually, the mean. Actually, we talk about the standard deviation, the SD square, okay, the N, all it refers to statistics. Okay, you can also go through the book and you can find different meanings, but actually different definitions, but all of them actually the same. So I hope now inferential, the meaning is clear, that how you, let me just make, erase it so that you can read. Okay, so here it consists of methods for drawing, okay, measuring the reliability of conclusion about a population based on information obtained from a sample of the population. I think now it is clear that what is population, what is sample, how to get sample from population. I think there should not be any doubt. Now, the next thing is about estimation. Okay, what is estimation here? And actually, again, because I have already said that you infer this information, or you draw the information from population. So what is hypothesis? Basically is a statement that you are going to test through some analysis. For example, I tell you, when I was doing PhD, I assumed that because my area was interest-free banks in Bahrain. So I assume that interest-free banks in Bahrain had or are grappled with more risks than the conventional banks. That was my hypothesis, because this I learned from readings, from literature review, from my own I would say observations which had no basis, actually, because I was reading some papers and then I assumed that, oh, interest-free banks are grappled or having more risk, actually, sort of risk, than conventional banks. But when I actually performed my study, when I went to Bahrain, I stayed there, collected my data, did some research, and found that these banks are actually less riskier, for example. Okay, so your hypothesis is basically that you assume in the beginning of your research, and that you have to the test you have to perform. And testing of hypothesis is very much a part of our syllabus. After 2 weeks, we would be coming to testing of hypothesis. Okay, there are different types of tests, Z test, T test, all tests I would be covering. Okay, we will be doing it in 3rd week. So all entire roadmap is ready. Okay, there'll be no problem at all now. We have already covered difference between the population and sample. I assume that you have learned, but still, if you have any problem, you can send an email to me. You can write to me. I would, if possible, I would reply immediately, or I will try to solve. Now, we have been talking about the sample, the population. But important concern, I think the second most important concern is that how are we going to actually collect the sample? It's easy to say that, you know what, you get all information from here, you know, sorry, from here to here. You can get all information from here to here. It's easy to say. But actually, what process should we follow? How can we get all the information, you know, that is useful for us, that is going to make sense? Actually, maybe we spend a lot of time, you know, in collection of data, but at the end of the day, or, you know, after a couple of months, and, you know, the time period we have spent, we get nothing out of that. Okay, so the next topic is called the sampling, you know, that how you are actually the collection of data, you know, what you, or data, the sample actually simply means that. Okay, collection of getting so far, there is no problem, all of you?
No.
Okay, very good.
No.
Okay, very good. Okay, now our next topic is called sampling, classification of sampling techniques. Actually, the word you can see on the screen called the, you know, probability of, you know, probability sampling techniques and non-probability sampling techniques. Okay, what is probability sampling techniques? Again, the same diagram, you know, that we have been drawing about population and sample, that if you draw information from you know, population, then you have actually, and in fact, in day-to-day life, when you are told or asked that you have to collect the data, so the first question comes to your mind, that how am I going to collect the data? You know, what would be the method? What would be the tools that I'm going to use? And a lot of concerns, you know, when a PhD student, you know, the first concern of PhD student, or you know what, that's the scholarship, you know, the fellowship. Are we going to get a scholarship? You know why do we need scholarship? We don't, you know why? Because we, as a PhD student, I mean that, because we have to go and collect data, we have to spend a lot of money, you know. Let's say because when you do your research, maybe you would be traveling to different countries, so you need housing, lodging, and all sort of things, and then, you know, transportation. Why? Because a lot of things are involved. Actually, you have to make your roadmap, you know, very clear. Okay, so are you simply going to just take sample from the books that somebody else has used already? Or are you going to collect sample your own, that we call primary techniques, right? Or when you are getting information from others, the data from others, we call the secondary techniques. Yeah. So probability sampling is basically refers to each person in the population has the same probability chance of, or probability and chance of being selected. For example, when you have this population and you have to collect this sample, let's say these are items, these are items, these are items. So you can select maybe this, you can select maybe this, you can select maybe this one, maybe this one, maybe this one. You know, everybody or every item has an equal chance to get selected, right or not? When, as I said, when you go to the field, okay, for your research, and you have to, you are very concerned about the life, okay, standard or standard of living in a particular country, you go there and you ask questions, you know, whomsoever you find on the way, right, on the streets, doing nothing, sitting in the park. So it could be anyone, right? And that's called basically the probability, you know, or a sampling technique, that we, where each element, I have used the word person, but you can also use the word element, that each element or person has equal chance or to get selected, okay, for to come into this, actually to come into the sample. Non-probability sampling techniques basically are the techniques where probability is not used. What does it mean? It means that we don't have a big population, actually. I would say we don't have a choice to select, no option to choose. No option to choose. And here we have option to choose because we have such a big population, but here we don't have. Let me give you an example. Let's say you are doing a research about a very sensitive topics. Let's say AIDS patients. This is the disease which nobody wants to disclose, right? And now what they do, when can you go into the street and ask, hey, are you grappling with this disease, or do you know somebody who is having this? So you don't have option to choose. You don't have, actually. So what you do, you apply some different sort of techniques, where you can get the data. Because, and maybe say criminology, criminal, okay, you want to perform a study, or do a study related to who has been in jail, in prison for 1 year. Okay, 1 year, sorry. Sorry. 1 year prison. 1 year prison. So this is something that nobody will tell you, right? You're gonna go to the street and ask, have you been, have you got arrested, or have you been, in prison, or blah. They would not tell you. So you have to apply non-probability sampling techniques. I hope it is clear. Now, number one is simple random sampling techniques. That is from the word itself, that you do randomly. You just go and collect some information. Okay. You want to know about, depending on your research topic, you just go and collect some information. Okay. And the next one is, let's say, for example, this is my basket. This is my basket. And, I have, let me tell you, I have different balls, or the with different colors. Okay. Now I'm asking you, hey, what is the probability? What is the probability of, this is parrot green, the green being selected? So, and what is the probability of red being selected? What is the probability of this is pink or yellow kind of thing? So this being selected, and you have one chance. So the answer would be that all of them have equal chances to get selected, all of them, because you have options. And this is called random selection, simple random selection. Now the next is stratified sampling. Okay, what is stratified sampling? Where the data is already in strata. The meaning of strata. For example, first, let's say, let me write here. Firstly, you create groups. For example, in this, I did not create groups, but here I'm creating strata. Let's say this is my male group. This is my female group. Okay, this is my male 18 to 25, or 18 to 25. This is my female group 18 to 25, like that. So you create strata. Okay, or strata means you create actually the groups, the subgroups, groups and subgroups, and so on and so forth. Okay, you refine your data. You refine your sample, I would say. That the more you refine, the more you would be closer to the mu. Because what you are trying to do here, that you are trying to reach the mu, because you believe that what I am, as I given an example, you went to Japan and you found that your friends do not eat sushi, and you come back and you say, hey, You know what? Japanese do not eat sushi, right? Because your selection of sample was not correct, was not effective actually. That's why you couldn't reach this. But your objective is to reach this. Okay, so in order to make, so now you may ask me, like, Kashif, why are you focusing on, why are you focusing on reaching this? Because here the question is about the usage of statistics actually. What is the use of statistics? Like, let's say, because if you have correct information, then only you can make the correct policies. If you tell me, if you say, hey, nobody is dying of corona in Kyrgyzstan, will there be hospitals? Will there be more concerns from the government? So we have to have accurate information in order to have effective policies. And that is what you call the very thick, in thick line, the usage of statistics, right? So that's why that the more accurately you are reaching the mu, the more accurate, information you'll get, and accordingly the decision making or the policy making would be implemented. I hope it is clear, the stratified sampling, that you create strata, right? Now the next is called the cluster sampling. And you know the meaning of cluster, but you know the what you call this line, the cluster. Like, for example, when you go and collect sampling, you consider the region, you consider age, you consider, what you call a gender, okay, you consider education, you consider all sort of things, and accordingly you collect information. So I would say in stratified sampling in general that you have to create, but in cluster the groups are already created. Just recall my first example about the trees, that how many trees are being cut in every day in Kyrgyzstan, in Bishkek. Now it depends on, because not everywhere there are trees in in Bishkek. I live in the area where a lot of trees, but in city center are very few because of the the malls and all the markets. So you have to consider the region as well. Then you have to many things actually that could help you. Cluster sampling. Next is called the systematic sampling. Now you would be thinking, so where can we, Kashi, where can we get the information? So you can get information in the books actually, both books. If you haven't got, I guess you haven't got here. You told me, so I will be sending you, and along with the syllabus, and you can find all the information there. In fact, if you ask me, I can also send. There'll be no problem at all. Okay, so I hope it is clear, the selection of data from particular region. So we can say here the region, age, gender, etc. Pre-existing groups. Okay, now the next one is called the systematic sampling. That's very important, practically, theoretically, from all angles. Again, I'm going to draw the same diagram. Let's say when you have this element, okay, in systematic sampling, you come and you say, hey, I have to select a sample. Maybe you select a sample from here. Maybe you select a sample from here. Maybe you select a sample from here. Right? Maybe you select a sample from here. Like, recall your experience in Japan, that you went to Japan and you met just few friends. So what systematic sampling says that if I collect all information, just this sample, then can it represent the whole population? Can my mean represent the whole, mu? No, it cannot actually. Why? Because you have selected sample just from one place, one corner. So in systematic sampling, what you do, generally, you do like this. You select sample from from every corner, nook and corner. But practically, is it possible? Not possible. Okay, theoretically, it looks good that you draw a chart and you select each person from each corner, it looks good, perfect. But practically, are you going to draw a chart? Not possible. So what you're going to do, what do I mean? I simply mean that, again, the word systematic. For example, I have 100 people. Let's say my N is 100 or 100,000 or 1,000. This is how my data is lying. Okay, this is my data. Okay, everyone is person or element. What I'm going to do, I'm going to select every 10th or every 5th, 1, 2, 3, 4, 5, every 5th, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Likewise. Now, practically, when you go on to the study, doing research about, let's say, COVID patients, what you're going to do, you are not going to select patients from a particular hospital. You select three patients from hospital A, 3 patients from hospital B, 3 patients from hospital C, likewise, and different ages, different genders, different exposures. Then only you can actually arrive, get, and this the accurate information. That's called the systematic sampling, where you do the things systematically. You just, you want to know about COVID patient and how many people died. You just went to 2 hospitals, get all information, that's all. No, that's not the way actually. Maybe, the hospital surrounded by, more COVID exposures actually. Are you getting my point? So this is called, there are 4 different types of probability sampling, where, and everybody, for example, in this, everyone has equal chance to get selected. Okay, now coming to the non-probability sampling, which is again important, but very less usable. We don't use a lot actually non-probability sampling, and that's why most I would like to just, but I would like to give you an understanding. Then if it is probability, then what is non-probability sampling techniques? Okay, and what is the use of that? I have already given an example of AIDS patient and criminal, and something where you don't have data in bulk, you have to rely on. But how can you do this? Let me begin with convenience sampling first of all. The whatever is convenient for you. What does it mean? Oh, well, by the way, sir, so everything is convenient for us. No, I mean whatever is available. Whichever data is easily accessible. Let me write down: easily accessible, which you can easily access, right? Judgmental purposive sampling, that what's your purpose is actually, and accordingly you frame your data, because you don't have choices. So what you're going to do, you purposely, judgmentally, you create the data. Okay, you and what techniques you can apply, like snowball, for example. What is snowball? So you are, let's say, you come to me and you say, Kashif, I am conducting a research on like criminals, and do you know somebody who has been prisoned for 3 years or whatever your conditions are? And say, yes, I know somebody. Maybe you go to him and he will help you further to find more. So you go to him, you go to criminal A, okay, and this, because he is a criminal, so he must be knowing somebody. So then he sends you further, B, okay, C, and then this guy sends you further, snowball. That you push the ball, and then and you push the ball with force, and this ball is going to push the other balls. Okay, snowball sampling. So this is one way of, sometimes, like, and we receive this day-to-day life. I'm also getting some emails sometimes that you are in Central Asia. Can you? I'm not from Central Asia, by the way. So are you? You are from? You are working there. Can you? I'm doing a research on Central Asia. Can you please forward this information to your students? And then I'm sending. But I have limited students. I'm teaching like 200 to 300 students, but the data size would be, like he or she wants like 1,000. Then I request my students to please share with your friends, and that's called snowball sampling. Okay, quota sampling actually. quota sampling is actually where you create the conditions, okay, where you create the conditions. For example, as I mentioned, that you are looking for a criminal, but this criminal should not, like, he should not be a murderer, for example, or he should not be a thief, sorry, for example. You could, he should be involved, or he should have been involved in different, criminal acts. So where you create the conditions, I would say, okay. And again, here when you create, because when you are interacting with the large population, you don't have actually, you don't find comfort, yourself comfortably creating conditions, because your data depends very much on the respondents, that how the respondents are going to react. Yeah, but in quota sampling, you can create the conditions and you can create some quota. Quota, for example, there's a job vacancy and there's a quota for particular, let's say for females. So they have already created a condition, whereas males cannot apply, right? So quota sampling. It's already, I hope it's clear. If you have any doubt, maybe you can discuss with me. There are 2-3 minutes left, and I hope you understand. From tomorrow we will be discussing about statistical design, and then we would be moving on to descriptive statistics. You know the term, but from tomorrow we would be actually doing some questions, and tomorrow we will finish descriptive statistics, and on Friday we would be looking or seeing or learning the application of all these descriptive measures: mean, mode, median, standard deviation, and sort of some interesting topics we would be discussing tomorrow. If you have any question, you can ask me.
Professor, are you going to send us a syllabus concerning the homeworks, midterms?
Yes, that's what we are discussing. As I said, now I'm going to send you syllabus and the books and the assignment in couple of hours.
Thank you.
Welcome. Okay, guys. So tomorrow at 9 a.m. in the morning, we will be continuing from statistical design. Okay, and then moving on to descriptive statistics. Okay.
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 Bye.
Thank you.
Thank you so much. Thank you so much for. Okay.
Thank you. Can I ask you a question?
Thank you.
Yeah. Please.
Thank
Please.
you for
Nice
the
day.
class.
What kind of version of SPSS we have to install?
That's an important point. Tomorrow, any version. Actually, in SPSS is like Microsoft.
Yeah, I have 26.
No problem. I use 24, 23. It doesn't matter.
Okay.
It's like a Microsoft. Whatever the version you use, there's hardly major differences.
Yeah.
Yeah. Okay. Tomorrow I will make an announcement about this also. Okay. Okay. Bye. Take care. See you tomorrow.
Goodbye.
Goodbye.
Bye. Okay. Goodbye.